Welcome everybody to the new analytics measuring today's communications. I'm here with Leo Irakliotis. Leo, how are you today?
Very good, James. Thank you. How are you?
Good, doing very, very well. Leo's decided to join us today. I want to thank you for joining us. Well, we're going to talk not so much about CIW at the beginning, but about social media analytics, different types of analytics, and making the most of analytics models from search engines, and how to extracting and archiving data. But we're going to focus on the importance of big data. What it means to collect data and turn it into intelligence, and skills that will put you on the fast track and jobs in these areas. So there's the agenda. A bit of an introduction if you don't know who we are. So I'm one of the presenters. I'm James Stanger. I'm President and Chief Certification Architect of Certification Partners. Worked for years in social media, designing certifications, also doing a lot of writing, for example, for Ubuntu User Magazine and for Linux Magazine. I've done a lot of technology consulting over the years, as well as curriculum development. Leo, whom we're very happy to have here, is the National Director and Dean of the College of Information Technology. Sorry, I'm tripping all over myself today, Leo, at Western Governors University. Formerly with the University of Chicago and elsewhere, including MCI, where you worked with Vint Cerf. What was it like to work with Vint, by the way?
It was like you were in the presence of an angel.
For those of you who don't know,
it was great.
Go ahead, Leo.
He was driving an interesting innovative research and development group at MCI. And it was possibly one of the most illuminating and education experience I've ever had in my life.
Absolutely, I would imagine. For those of you who don't know, Vint Cerf is one of the many fathers of the internet, and so a true originator, and still doing a lot of stuff for Google. Isn't that right?
Yep, he's an internet evangelist for Google right now.
Right. So, Leo, you've been a university instructor and dean not only at Western Governors University but elsewhere, but you're also an expert in data analytics. You know about big data, about data mining and architectures, and also are an expert in intellectual property issues. And so this is why, folks, we've brought Leo on board to talk about these things. We're not going to talk so much about theoretical physics, but we are going to talk a bit about diving. No, actually we are. These are some pictures that Leo has taken, including the one at the let's see, it would be the upper left there. That person giving you the peace sign there is me, actually. Leo and I went diving down in Bonaire, and these are just a couple of pictures there. And I understand, Leo, you were back at Bonaire here until a couple of weeks ago. You were there for a while. How was the water there?
Perfect, 83-degree water, 120 feet visibility. It's a great place for diving. You know that by now yourself, right?
Yeah, yep. You introduced me to it, and I haven't recovered since. So just want to let you know. So Leo, in addition to his intellectual pursuits, is a fantastic diver. Learned a lot from him. So and I trust you all are going to learn a lot from this webinar, which is brought to you by CIW, your Web and Internet Certification. We're a skill-based education standard. We take a very comprehensive and holistic perspective on certification, and where we provide courses and certification exams in web development and design, but more importantly, the internet. And so we can our CIW Foundation's product is perfect for things such as learning about big data. And the idea with CIW is we put people on a lifelong learning path, not just a vendor's product treadmill, because we teach skills that everybody needs to know about the internet. We're vendor neutral. We teach open source stuff, proprietary knowledge. We're a globally accepted cert with over 65,000 certified individuals. So let's get into the meat of this presentation about big data and about the new analytics. Let's just talk for a second about how much data we create in the world. And Leo, if you have any additional insights on this, just feel free to join on in. We found I found by doing some research here, I think one of the great things about webcasts is you can have somebody do research for you, and then you can grab those ideas for your own classroom. So, so Scott Nason, for example, or Don Amos, feel free to grab this. And by the way, everybody will get a copy of this in PDF form, so you'll get a shot at using this. By one estimate, humans created 1.8 zettabytes of data or communication in the year 2011 alone. So if you look on the right-hand screen there is basically a comparison, as it were, of these data measurements, which are a little large. I remember back in the day when having 8 megabytes of RAM was a lot. I really do remember that. I remember having when 32 megabytes was a lot. And it's amazing to think now that it's very easy to have a terabyte drive. So a zettabyte, if you take a look at it, if you have 1.8 zettabytes, you're looking at basically like 200 billion high-definition movies. It would take you a little while to watch all of those movies. It would take even longer than Boston took to record its second album, which was a lousy album, by the way. But I just kind of wanted to give people kind of a comparison or an idea of the kind of data that is generated alone. So if a typical MP3 file is 3 megabytes, it's a little small, but if it is, think of that, right? A typical disk is between 500 gigabytes to a terabyte. So you would need 57 billion 32 gigabyte iPads in order to come up with this kind of data. And this stuff is generated all the time. Imagine what it will be in 2012. And because we're creating data at an exponential rate. 90% of the data in existence today, right now, was created in the last 2 years. So imagine the absolute mathematical or progress of data that we're talking about here. So what you have is that all of the data ever generated until the year 2003, according to Eric Schmidt, Mr. Google CEO, we create that much information every 2 days. Now, if you look through the history with the start of the with the start of the printing press back in the 1470s, that started an amazing amount of data flow back then. And at the end of the hand press period, around 1804, you have automatic presses starting to enter in and creating a tremendous surge in data around the beginning of the 19th century, of the 1800s. That's nothing, excuse me, compared to the kind of data we're talking about. There are 12 terabytes of tweets each day. How's that for alliteration? We have roughly 5 million trade events a day, stock trades, things like that. Visual News estimates that 2.1 billion people now participate regularly on the internet, 2 million Google searches a second. So how do we turn all of this data into something useful? And to me, it's an interesting kind of distinction that we have to make between data versus information. And there's a big difference between the two. Data is collected at random. It's raw, unorganized facts. There's little or no context that you bring to it, and there's no correlating factor here. I was talking to a friend of mine, Dwayne Hume, down in Florida, formerly of the Department of Education down there. He made a fun distinction between data and information, which is usable data that has been analyzed. It has points of reference. It is structured and interpreted. And Leo is an expert in being able to do just this. And so the idea is that you can take data, make it information that's actionable. And actionable information you can even call intelligence. And it's used to generate important decisions for governments, for corporations, science. Okay, it's a big one. Leo reminded me of that yesterday. That's actionable information that allows you to guide policy for your company, for your school, for whatever for whatever organization you're working for. And it allows you to attach significance. And so this intelligence allows you to safely draw conclusions. And it's more than just simple statistics. It's basically information that now has such value you can sell it. And let's take a step back here for a second and think about tools that we use every day. For example, Google. Google has done extremely well, we know, but the reason why they've done well is not only because they created a search engine that is able to do ranking automatically and then with keywords and with organic search, but they've done very well because they take all of our searches that we create, Leo, I don't know what the last searches you've done on the what the internet were, but they take those searches and the searches that I've made, and then they can turn around, analyze those things, and then start understanding what interests Leo Irakliotis and a million other people, and what interests James Stanger and a million other people, and they can start creating trends, and they can sell that information. This is where they generate a tremendous amount of revenue. So how do we analyze all of this data? Well, there have been entities out there for a long time who've been doing this. I think we've all heard of the Nielsen company. They're the ones that do the Nielsen ratings. There's a picture here on the screenshot of one of those boxes that some people have. Leo, have you ever been a Nielsen family? I certainly never have been. I doubt you have been either.
Certainly not. I'm not the typical demographic for Nielsen.
Yeah, I'm afraid I'm not either. But this whole thing that people know that Nielsen's for, the Nielsen company, where the little boxes that monitor you're watching, and then if you're a Nielsen family, you have a major say in what television companies do and what is made out there. That's only about 35% of their business, and it's probably not even that. I've heard lower estimates. Dwayne Hume, again, was telling me, right around 15% or so, but I was reading about 35%. Whatever the percentage is, the majority of their revenue, in many ways, is kind of what Google did. You could argue Google kind of took that idea from people such as Nielsen. In other words, they collect data, and then they extrapolate from it, and then they are able to sell that information. That's really where they get the majority of their money, because there are companies who basically say, we know the Nielsen's understand the interests of the typical demographics that are out there. And not only will the movie companies, television companies make decisions based on that information, but Walmart will come walking in the door and asking for information so that they can be in line with the typical demographic in various parts in North America. And there are situations like this, of course, worldwide. So companies today thrive on information. They gather information, they sift it, and they organize it. And they do this to discover trends. And the reason why they do this is it's all about margins, people. Think of this. If a Fortune 1000 company can increase the usability of its data by just 10%, which is actually a huge number, that company could expect an increase of over $2 billion just by collecting the information that they get, the data that they get every day, by collecting it and then starting to analyze it. So think of the win that you get by spending some resources on big data, on analyzing and getting turning data into information. Consider the reward that companies get. And this is why big data is so important. Leo, what are some of your thoughts about the importance of things such as data analysis, data gathering, and big data? I'd like to get your perspective on that, because to me, the reason why companies are interested in big data isn't because they're geeks like us, right? They love technology necessarily, but because they see some sort of return for it.
And it's exactly that, James, because an increasing number of corporations, even in the small and medium-sized enterprise space, begin to see the value of big data. Not that they ignored that value before, but what is different now is that even to the smallest company, the technology for analyzing data, large amount of data, is now a commodity, is now something that they can afford, and they're becoming interested in using that commodity. I co-authored last month a report for the Tech America Foundation on big data, and if anyone is interested in that report, you can find it at, if you Google Tech America Big Data Commission. And what we saw there was that the inexpensive availability of CPU cycles through cloud providers or through inexpensive servers make access to data analytics now very appealing to a number of companies. And anyone who's doing transactions, whether you're selling running shoes at a locally owned store, or you have a small franchise in a region selling burgers, you're doing transactions, you're collecting that data, you want to analyze them, you now have access to tools that give you some predictive forecast, predictive analytic capability, and that's for the price you are paying for that. You can't ignore the opportunity to improve your operations based on that forecasting. So that's what we see now. It's the commoditization of the predictive analytics technology that makes it so appealing.
So who had this technology before? I mean, it was basically the purview of very large research institutions, very large companies, right? And now it's made it into more typical businesses. That's what you're saying by commoditization, right?
Right, right. I mean, if you think about it, what you can do today even on a moderately new laptop, you can run Hadoop on a laptop. The things that Hadoop does, and I don't consider Hadoop to be by far the best tool for parsing and analyzing big data, but it's a pretty decent one nonetheless. But what you can do with Hadoop today, you couldn't do it 10 years ago on your desktop or 20 years ago on a mainframe. But the processing power is now there for you.
So it's more readily available. Very good. And folks, we'll be getting into an overview of Hadoop and alternatives to that in just a few slides.
We had the big corporations that were running serious mainframe shops, and of course government agencies that could afford this kind of computing power, the national laboratories certainly, but it took a while for that technology to become financially available to smaller operators and smaller companies. And now everyone who has a laptop that is a year old or maybe 2 years old, you have quad-core Intel processor, you have a parallel machine in your hands. You can do a few nice things and analyze data and do some forecasting for your business.
Nice, nice. So, in fact, the idea of applied examples when it comes to this use of information is you can grab all of the social media information that's happening now, all of the tweets that are relevant to your company, and basically you can find information from all of that. You can turn that data into information by looking for metrics and studying trends and reputation and using this information for product improvement. That's the general rule these days. And we're going to talk about search engines and then get into a little bit more into big data. So first let's talk about some of the things we promised that we talk about with the webcast, about social media analytics, including basically trending and reputation analysis. So analytics focuses on several key issues. First of all, trending, which is basically events over time, kind of like a stock ticker. And you basically look for trending of information, which is very important because it helps you understand your brand better and its perception in the world. It also helps you take a look at the products that are out there and you can improve them. Another thing when it comes to social media, the discussions, are they bidirectional or unidirectional? Back in the good old days, 2010, it was very important to talk about how important, if you were on Twitter, for example, Facebook, any of the social media, even Google+, were you just the only one talking there, folks, or are there people responding, and are you engaging in a conversation? And that's the important thing. There's also, you can talk about reputation analysis, what people are saying about you not only in your own forum, but also elsewhere. And then you can monitor discussions about you, but not necessarily involving you. And it's all about mentions, good and bad. Just like back in the, you often heard the old cliche, there's no such thing as bad publicity. That's possibly a similar thing to say when it comes to Twitter. So let's talk about some of the social media metrics that are out there that are important. And Leo, I wanted to avoid kind of the tool parade approach here. In other words, saying, hey, here's some great tools for Twitter. I mean, that's fine, but I think it's more important to think of the function and the actual important metrics, and then kind of apply some tools to it. So one of the first things has to do with mentions, right? And you can grab those from Google Alerts, and that's based on keywords. So you basically set up Google Alerts for various keywords that are important to your particular interest. And that interest doesn't have to be some sort of product-based interest necessarily. It could be personal. It could also be professional. And basically what you can do is once those keywords are named, then Google Alerts tells you exactly how that has happened and when that has happened. And you'll have to do a lot of tweaking, not only in your conversations, but in the keywords that you track. But you don't just have to stick with Google Alerts. You've got additional tools, and I thought I'd throw some of the top ones out there. Tactical Marketing, Tracker, Brand's Eye, all of these do a very nice job in helping you track mentions. There's also a URL I've given there that does a nice job talking about reputation management tools. And it's important to find out when you're using these tools, who does your audience listen to, and not just necessarily what does your audience listen to, what platform. Is your audience a Facebook audience, more of a Twitter audience? Make sure you choose the right platform. And what is your audience, who does your audience listen to? A couple of things here, additional metrics to think about are metric 2 would be brand. So Brand Watch, Brand's Eye, Alterian, these are all very effective tools for understanding your brand's perception in the world. And also the next metric, I should say metric 3, has to do with conversations. Not really the same thing as mentions. They're basically sophisticated dialogues and exchanges that can take place over days or months and can be negative or positive, as I mentioned before. Another metric there is demographics, and they're very critical to understand when it comes to understanding not only who is listening, but what are their basic interests. And so Ranker, it was an early crawler that basically it still exists, and it's a crawler that goes out there and checks out all of the sites that you tell it are important. And it has a tiered pricing structure, so you can get free for the free version, you get some nice information. But for the more spendy it gets, it does a very, very nice job of collecting data. And just as Leo said earlier, that a lot of this the capability to capture data is now available to the more rank-and-file company in person. You have these cloud services basically available to you to do very sophisticated analysis for you, or at least data gathering for you. Then you do the analysis. Pingdom survey also. Pingdom did a very nice survey talking about the types of demographics that are out there, and I grabbed a screenshot from that survey talking about age distribution on social networks. This can help you as you go about branding your product or understanding what you want to do with Facebook or what you want to do with Twitter, going out there and saying, well, where should I go for a particular demographic? It's very, very useful information because that allows you to have the right kind of dialogues with people. And the dialogues or exchanges that can take place over days or months. And again, they can be positive or negative because it helps you understand exactly the place of your particular brand or your particular interest in the world. Now, when you're getting social media metrics, there are a lot of native tools there. LinkedIn provides their own, and you can find out, as Michael Shura was telling me, one of our marketing people, about conversations, who the biggest contributors are, and who's saying it and what are they saying. Hootsuite is a very nice tool. It's pretty standard out there. A lot of people use that more for posting. At least that's what I've used it more for. I think Mike Shura has as well. It also does some nice analytics, and you can see replies on a specific string. These are all examples, I think, of what Leo was saying, where a lot of technologies, a lot of uses, a lot of technologies that were out there, have been out there for years, but were really only available to the largest institutions, are now available more and more for people. Here are a few resources that you can have. I'm not going to spend an enormous amount of time on these individual resources because, again, you'll be getting a PDF of this, of this document. But some of these books have been out there a while, or these texts have been out there a while, and these happen to be freely available. Some of them, not every page may be useful, but each of them has good sections in there that will give you some very good insights. There's The Wealth of Social Networks, it's called. Another one's called The Essential Guide to Social Media, The Future of Reputation, and Where the Fish Are. These are standard resources out there. If you haven't looked at them, I suggest you take a look at them as soon as you can. Strategically Social and Time Management is another one. I like the Time Management one because it does a pretty good job of saying just because you're up on social media and looking at stuff doesn't necessarily mean you're being productive. Well, ways that we can make the most of analytics and search engines. First of all, remember that there are various things out there that you have to understand. One of them is organic search and direct and keyword-based search and social networking. And make sure you get referrals from a trusted resource. And you can get combinations from any of the above. And consistency is critical. You have organic versus pay-per-click, of course. Organic is search engine optimization, not based on tricks, but it focuses on natural usage patterns. What does natural mean? Well, it depends on your audience and what is natural to them. And so that's where you get your demographics. And this is where you use your information gathered from various resources, Google Analytics, Hootsuite, whatever, and you alter your approach based on that kind of information. And then you can start moving on to things such as pay-per-click. Leo, what kinds of information have you been able to, what kinds of work have you been able to do in regards to working not necessarily on search engine optimization, but understanding from a big data perspective how people can improve their web presence in regards to all the data that they can collect?
Well, I can answer this question in two ways, James. As a consumer of data analytics services,
yeah.
but also in the past as a researcher in databases. Let me give you my perspective as a consumer, because this is what I do nowadays most. We have a university that is technology-driven, online presence, and we want to be adaptive to the expectations of our students. We have about 40,000 students enrolled in our various programs across our colleges, and we use analytics about their usage of our web page, of the web page once they get authorized to use the intranet services for the university for delivery of instruction, etc. So we look at the usability they have, their usability patterns. So we create an individual student profile so that when you log in back to our data, to our website, the web server sorts of know what links you're using more often, what are your most recently visited pages, and you have them immediately available to you within a one-click distance instead of going down one or two menus. So we improve efficiency of usage of the web page by analyzing your usability of the website itself. So that's one example that I see as a consumer. As a researcher in big data science, when I was still an active researcher before I became a university administrator, I looked, again, it's all about optimization. It's all about minimizing response time so that the end user will get the satisfaction from the immediate response of a website or a web service for that matter. And again, what you look there is usability pattern information about things that a particular user is doing at your website, or if you're having a retail website, the particular departments that a particular user is visiting. For example, if you went to Amazon about in the last 3 months and you looked at my profile, James, you'd see that I was browsing a lot of diving equipment, diving accessories that Amazon might sell. And after 2 or 3 visits around their dive supply store on Amazon, whenever, and everybody I think on the call has that experience, Amazon tunes the first page that you see when you log into your Amazon account with things that you searched in the past, and that according to their analytic model, they get the idea that, you know, you've been looking at this piece of scuba equipment for the last 2 weeks. Maybe we can promote it a little bit, maybe we can sweeten the deal for it, maybe we can showcase it in a more fancy way on the landing page as you log in. Come on, let's make the transaction, buy the item, kind of thing. So that's another aspect, especially for retail web owners. And something else that I'm looking at recently, and it's very interesting because it involves healthcare services, is the ability of patients and doctors to navigate through medical databases that are available online based on their usability pattern. And when you combine a patient and a doctor, with known records, maybe you can narrow down and optimize their usage of the website of the medical database even better, because you know the specialization, the specialty of the doctor, you know the historic medical record of the patient, and you can sort of guess what they may be looking for given past searches from these two individuals. So that's another fascinating field, because there's tons of data out there for that.
There's so much data, and it's not particularly organized particularly well either for the medical folks themselves in their own profession, or for consumers who want to get to them. So yeah, it is a major area that big data is used, and combined with things such as organic and even paper, not so much pay-per-click, but organic SEO. And see, this is how you can use all of these different services. So basically, if you are doing any serious work at all, as Leo just talked about in terms of the medical profession, but any serious work at all in terms of Twitter, Facebook, all those platforms, and modifying a website or modifying a particular teaching approach or whatever, you've stepped already into the big data world even without realizing it, sounds like. Does that sound about right, Leo?
Yes, it does.
Well, let's go ahead and talk a bit about extracting and archiving data from social media, and there are kind of two essentials here. Once again, two-way conversations aren't enough. The dialogue model is kind of old school, very 2010. Now it's all about data extraction. What does that mean? Basically, it's all about leveraging data. And in the same way Leo was talking about with the medical profession, do you have access to the data so that you can crunch it? With social media, you can narrow things down very nicely. You can analyze direct and indirect conversations. That means direct conversations between you and others, whether that be a consumer, whether it be students, what have you. And then you have indirect conversations, which is basically not involving you. What kinds of things are being said out there, and how can you go ahead and respond to it? And the key is also finding influencers, which are not all found in cyberspace. And when it comes to working with the data that you grab, and let's say you grab a bunch of data from Hootsuite, or you grab a bunch of data from Tracker, and you need to use that and extract it. Extraction doesn't necessarily mean, well, it needs to be put in the right format. It needs to be put in a Word doc, PDF, a spreadsheet. That's really not what I'm talking about. I'm talking about the ability to take that data and make it so that it's information usable by people in sales and in marketing, or making it usable, as Leo said, in the medical, for example, in the medical profession, where you can take that data and make some changes there. So that is kind of the importance here. But the idea is that you can take this information and work with various influencers. If you have a project that you want to get started or feel is very critical to the company, you're going to need to work with people, executives, people in sales and marketing, and you're going to have to get that data represented in the right way and extract it into a form that they understand. Very possible that people who are in various positions of authority, power, who can really get things moving for you, they will not take seriously at the beginning a lot of this data, because with names like Hootsuite and Tracker and Birdseye or whatever, it may not quite seem like serious data, but in fact, of course, it is. So when you're working with influencers, find ways to get that data so that it's truly credible and truly important. So again, make it all convincing, and consider your audience. Are they executive? Are they sales? Are they marketing? What is the purpose of this data? And focus on customer feedback. You know, back in the day, it was the customer is always right, which is a very broad way of saying much more important things, such as the customer helps us design our website, or the customer helps us design our product. And that's really where big data becomes a very practical and important thing. So Leo, let's talk about a couple of terms and a couple of things here having to do with big data. What I put here on the website, and feel free to expand on this or qualify it in a way, or say, well, that's not quite it, here's how I look at big data. But basically, it's the ability to process mega-large data sets, and it's a name for describing how to handle the volumes of data generated by today's networks. And these networks, by the way, include more than just you know, web traffic. It includes your cell phone. It includes all of the data that you generate on a daily basis, whether it be when you go to the store. There's a lot of data that is generated when you walk through a store, make purchases. Trust me, that data is used, it's folded, it's spindled, it's mutilated to draw all sorts of conclusions about you and the millions of other people who are doing the same thing. So there's a sheer volume, sheer amount of data that is generated. And isn't it really kind of volume, velocity, and variety, Leo, that are really the major parts here of understanding the big part of data? Aren't those the three elements that we really need to focus on? How quickly it's generated, and then the formats and the platforms used that are used whenever all this data is generated. Aren't those the big three?
I'd say so, James. I think that if you look at the Tech America report on big data, there are some other characteristics, but the consensus is that volume, velocity, variety will add validity to it, maybe a third V. So it's the 4 V's: volume, velocity, variety, and veracity or validity, however you want to describe the quality assurance aspect of the data are the very important. And I would also say that it's not just the ability to process the large data sets. Certainly that is the main thrust of big data, but creating, managing, and collecting the data as well is part of the big data scope in terms of how do you collect the data, how do you store, how do you manage, how do you govern those huge data sets. Those are elements that are known to us through data warehousing and database management anyway, so it's not anything new. It's the sheer volume and the opportunity to apply some serious statistical methods on those data sets now that make big data so unique in terms of extracting knowledge and information.
This is good. Thanks, Leo. When you're talking about validity, what are some of the ways that you can go about trying to make sure that this data that you've turned into information, how do you know that you're not drawing wrong conclusions or listening to the wrong data, as it were? What are some of the reality checks that people do?
Well, when it comes to data that are generated by your own company, you have a very good idea about the provenance of that data. But when you're a third-party analyzer, a third-party data analytics provider, you really have to ensure the provenance of the data sets, make sure that the data are reliable in that respect, and always keep in mind the old adage of data mining and statistics. Correlation is not causation. You might, it's fascinating that you look at large data sets and you see all these correlations and you tend to immediately identify causal relations there. Correlation is not does not always indicate to a causal relation, so be a little bit careful with your statistics and your control groups.
Okay, very good, very good. Thanks, Leo. And the next thing that we want to talk about is the fact that it has to do with the variety. We've got social media, searches, and then human interaction, mobile phones, purchases, credit card, even RFID, I suppose, inventory reports, and manufacturer orders. And we have to get all of this information available. And I think it's this kind of information that led Eric Schmidt. I don't know if any of you remember, it was a couple of years ago when he said, we know where you are, we know where you've been, we can more or less know what you're thinking about. I think that's Eric Schmidt kind of entering God mode there. But isn't that kind of what Eric was talking about here, Mr. Schmidt anyway, was talking about in terms of, he, as a company can at least feel very intelligent about the consumer because they analyze this kind of data. They check their data sets and they work on it. To me, that is this where Schmidt was coming from in terms of being so confident in understanding where his audience is.
So,
hello, Leo.
Was that a question?
Yeah. Yeah. Sorry. Yeah, sorry. Isn't that kind of take a look at that quote there? Isn't that really where Eric was coming from? Because he said, look, we study social media, we study searches, we've been doing it for years now, right? And so Schmidt is basically saying, we do a lot of data crunching. What do you think? Do you think they know that much? Yeah.
I do, and it didn't have to be big data before we knew that much. I think that, and I've been saying that to my students when I was teaching database courses in the past 15 years, as early as 15 years ago, James, that can you imagine if your health insurance company acquired the records, your transaction records from your credit card company, and they find out that you're spending a lot of money buying red meat and wine? Don't you think that they may use that information to jack up a little bit your premium? Because if you're buying a lot of wine and a lot of red meat, it means that you eat a lot of red meat and you drink a lot of wine, and that puts you at a risk for coronary disease. Although you can argue that the wine benefits offset the the damage caused by the red meat. But
Right.
you know, if the point is that if an insurance company had access to your credit card records and you were a serious credit card shopper, that you use your credit card for most of your transactions because you like getting the points or the miles or whatever benefit your credit card offers to you, do you think that the insurance company, the health insurance company, might use that information to say, wait a minute, we need to modify your coverage or your premium? And,
you know, I think that's one of the negatives, yeah. I think it's one of the negatives here is that once that information gets there and people start extrapolating, I mean, I hate to sound kind of Minority Report-ish, you know what I mean, that movie with Tom Cruise back in the day, right, where they knew you were a criminal before you became one kind of thing. But keep going, Leo. That's interesting.
It's, you know, I mean, you can always start shopping with cash only and
go off the grid, huh?
Yeah. Get off the grid in that respect if you're that concerned. But you know, I will also make the argument that if your health company, if your health provider, your health insurance company is upfront with it, and they say, listen, we're monitoring your consumer habits and we're adapting your coverage and your premium according to that, in some extreme way that I'm not advocating but I'm not dismissing at the same time, I would say that this might modify consumer behavior. Is this the kind of consumer behavior that I would like to see? Is this the kind of moderation of consumer behavior that I would advocate for? Probably not. I'm a university professor. I'm an academic. I prefer more of an education approach to informing consumers. But you know, that's another way to do it. Look at Progressive, the car insurance company that puts that little data reader in your car, and according to how your drive behavior, they give you a discount or they take away the discount. When they were test driving that concept for about 5 or 6 years, one of my former students was the project manager for that, and for a while the chief technology officer for that company, and he was telling me that when they were piloting that service, and the pilot lasted for about 5 years, they were giving everyone a discount just for installing that thing in their car, and they were giving the discount to incentivize drivers to have that data collection box in their cars. And even if you were driving aggressively, they would not take away the discount, because during the pilot project, it was much more important for Progressive to collect behavior data, even if that behavior suggested that some drivers did not deserve the insurance premium discount they were getting. But now that they have the data, they can say that, you know, you were driving on I-290 outside Chicago, and we know that the speed limit there is 55. You were doing 75. So, sorry, we can't tolerate that. If you were 10 miles over the speed limit, okay, maybe, but 20 miles over the speed limit is too much. We're going to charge you 20 cents extra this week.
Right.
And again, that might give drivers an incentive to be a little bit more careful. Again, I would prefer to see that consumer behavior changing through education, but sometimes money is a powerful incentive. And going back to your original question in a long way around, James, I would say that most companies knew your behavior way before big data was such a buzzword.
Yeah, that does make sense, doesn't it? Let me ask you this. You were talking about, for example, Progressive or whomever grabbing information, getting information, from the readers, and we've got a bunch of examples here from social media through various human interaction. When it comes to grabbing big data, let's talk for a second about dashboards. What is the importance of things such as dashboards in handling big data? There was a question that was asked earlier about this. So. How do dashboards help out there?
Dashboards are, at least, and let me make sure that I understand the question, James, because to me dashboards are visualization panels for big data rather than, so they are the end product of a big data project. So are we talking about the same kind of dashboards?
Yeah, I think so, yes.
So what dashboards are a powerful visual representation of a very complicated data set, or a very complicated, very large data set. And at least to me, and maybe I'm not the right person to answer this question, but at least to me, dashboards are directional maps of a dynamic data set. So, for example, as a university administrator, I have a dashboard indicating completion rates of students taking our undergraduate courses, and success rates of students taking final exams or and so on. And I have directional information that if I see that dashboard becoming more yellow than green, something's wrong and I need to look into it. So the dashboard to me is a simplified visual representation of a very complex data set, because at the end of the day we make our decisions based on an abstraction of the trends in a data set rather than look at every possible dimension. Remember that the data set, especially nowadays, a data set is a multi-dimensional collection of information, and as humans we can handle only anywhere between 2 and 6 dimensions at any given time. We cannot visualize more than 3 dimensions to begin with, but we can handle 6 or 5, anywhere between 2 and 6 parameters in a problem before we lose track of the key factors. And that's
to me, the dashboard is basically something that once you have started to narrow down on certain action items of the data, you've got a quick visibility into it. Like you said, a very complex issue, but it allows you to do more trending and monitoring. But I don't think you're going to be you get that kind of data or that kind of certainty or that kind of narrow representation of data until you've done a lot of crunching and a lot of adjusting of your thinking beforehand. Isn't that right? I mean,
that's true. I think there are 2 ways to designing dashboards. One way is that you tell someone what you think your key factors are in a decision-making space. That top-down approach is a projection of your own beliefs of how this data set is behaving or how the business should be operating. And that's sort of a narrow-minded approach, because if you're going to go into data analytics and big data, let the data speak first. And if they don't change your mind, that's fine, but give the data an opportunity to speak to you first. So you start with this big data set that, like I said, is a multidimensional data set. And there are statistical techniques to take that multidimensional set data, the many dimensions of the data set, and compress them to 2 or 3 dimensions that, according to the statistical analysis, are the principal components of that data set. And one of those techniques, as I'm alluding to, is principal component analysis, where you have a data set that has 100 parameters. You cannot visualize all 100 of them. You want to visualize 5 of them. What are the 5 most principal components of the data set? You can decide that question either based on your belief about the data set, which may or may not be objective, or by doing the statistical analysis and let mathematics tell you which are the principal components of the data set. And sometimes, and I've seen it, and I can speak to that example with United Airlines from a project that I did for them about 10 years ago, you'll be surprised what a more systematic, more scientific approach to the principal components of the data set might reveal about your business model. So just as a quick example, 10 years ago, I helped United Airlines develop a predictive analytics model for their Mileage Plus members, for their frequent flyer club, basically. And
Okay.
there was a prevailing mentality at the company about how frequent flyers behave. And when we looked at the data set, we discovered things that challenged that corporate orthodoxy in a way that they redesigned part of the services they were, to the extent that they had to redesign some of the services they were offering to Mileage Plus members, and as a result, they saw a high degree of customer satisfaction. I don't want to go into detail about the project. I can certainly speak about the project. If anyone is interested in hearing more, I'll be happy to take that offline. But sometimes what we see with dashboard design, which is the ultimate abstraction of big data set, is you're challenging corporate dogma and orthodoxy to some respect, because you discover things that were gone unnoticed before. You didn't have the analytic capability to see them in the first place.
See, that's the thing is, before information, I think, was basically allowed. The people administrators basically felt they knew exactly what they had to know, and yeah, big data can definitely challenge that. Okay, Leo, I want to talk for a second about the importance of understanding structured and unstructured data when it comes to that. For example, when you were doing the work with United, you were using frequent flyer information, right? So that would be structured data that you were being able to grab, is that right?
That was very structured. That was actually relational tables.
Yeah, so you're able to take that and extrapolate it. A lot of big data comes from unstructured data, right? It comes from various places, the variability that we were talking about earlier. And I think that one of the promises of big data, and one of the realities actually that's coming in, is in addition to things such as your United Airlines example, you're also able to bring in unstructured data. Let's talk for a second, the last few minutes, about Hadoop, MapReduce, and NoSQL, Leo. Because, like you've kind of been alluding to, there are companies that don't collect data. There are some who do. They collect bad data, or they don't do anything with it. And then there are those who have delved into big data. And there are ways in which you can delve into big data. Let's talk for a second about, for example, Hadoop. You're saying that it's not the only one out there, that there are other places to do it. But what does Hadoop allow you to do in grabbing structured or unstructured data and processing it? Could you give people an overview of that real quick?
Well, I think that that what you have here is very good in terms of a Hadoop overview. From a computer science point of view, I can speak to Hadoop. It's a Java-based tool for distributing for doing distributed processing, and ironically. As a computer engineer, as a computer scientist, I'm not sure if Java is the right platform for this, but apparently it's very popular out there, so it's too late to turn the river on this. The idea, fundamentally, if you want to go back to your college algebra and also to understand the beginnings of Google search Google search algorithms, it has to do with doing computations on very large but very sparse two-dimensional matrices. And we learn in high school or in early college how to invert a 2x2 or a 3x3 matrix. But what we also learn is that as the matrix becomes larger and larger, that inversion or multiplication operation that we want to do is becoming more and more computationally expensive. Certainly if you go to a 4x4 or a larger matrix, it cannot be done by hand. It can, but it will take a couple of days to do it. So, and the same thing applies with computers. As the matrices become larger and larger, it takes more and more computational time to do whatever operations you want to do. And when you look at those matrices, and we're talking about matrices that have 1,000,000 by 1,000,000 elements, so we're talking about 1 trillion elements in a matrix. 95% of those elements are zero, are blanks. There is no information there. So you want to find the areas in the matrix where there is some information and do focus your processing capability there. There have been in the past techniques and algorithms developed to parse that problem, throw out the blank space, the sparse content of the matrix, and operate on the aspect of it that has some useful information. So anyway, long story short, it's if you look at most data sets, they have a lot of noise, and the objective is how do I identify what is noise, how do I remove it so I will not be wasting computational power in it, and focus my resources on the useful part of the data. And there is where Hadoop and other parallel distributed techniques come into hand to help you converge fast to the useful part of your data sets. That's as best I can design it from an algorithm.
Oh, that's good. Yeah, that makes sense. So Hadoop distributes it. MapReduce, you're able to do some division of very large tasks or huge tasks into multiple tasks, and then you can come up with a nice summary of all that information that's there. So MapReduce is more of a computational paradigm. And MapReduce will sit on top or work within Hadoop in order to basically get yourself a nice summary of information. I just wanted to give people an overview of what those things are. So you have Hadoop, and then you have MapReduce runs on top of it. And NoSQL, in the last couple of minutes, we're near the top of the hour, Leo. Apologies, but I like hearing what you have to say. When it comes to NoSQL, I think a lot of people, right, Leo, think that it stands for, SQL is no good anymore. We don't use it anymore. When in fact, it's a supplement, right, to SQL, and that whereas SQL is relationally oriented, NoSQL stands for not only SQL, and it's a different architecture that allows you to very quickly and scalably work with a very large data set. Examples include couch.
Yeah, I would say it's a supplement to relational. I think that if you have skills in relational databases, and you know how to do conceptual modeling and empty relationship diagrams and implement them as tables, you don't have to worry about switching careers anytime soon. You look at NoSQL products like MongoDB, and you realize when you go a little bit below the surface, you realize that these are key value pairs of data sets. And the difference that you have between them and SQL are basically two fundamental differences. The concept of normalization is not there, and it's not a bad thing because those data sets, those NoSQL data sets, are produced in a mechanical way, in an automated way that ensures that even though you don't have a normal form standard applied to them, that there is no dirty data. There is no redundancies that might pollute your data set down the road. That's the biggest challenge in relational databases, how to normalize the data set so that you won't have to make changes in more than one place in your database when you need to update records. The other thing is that you don't have a set theory oriented language for managing the data in NoSQL. You can the data sets are more amenable to the map and reduce functions of Hadoop or other analytics tools, and that makes them appealing for some applications. At the end of the day, James, I'll say that if your data set is below 1 gigabyte, there is nothing that you cannot do on it with MySQL on a laptop. But once your data set goes above 1 gigabyte, you need a little bit more processing power, and maybe relational queries may not be the most efficient way to analyze the data. And that's where Hadoop and MongoDB and other analytics tools of that MapReduce family come handy. But I would draw the lines right now somewhere in the 1 gigabyte volume as to when you should start thinking about using tools beyond relational.
Beyond relational, something as NoSQL. That's a great rule of thumb. Thanks, Leo. That's good to know.
And you can challenge that rule and question it, but at the end of the day, there is a line, whether it's 750 gigabytes or 2 terabytes, there is a line at which point relational databases begin to perform suboptimal.
Suboptimal, not as quickly, and it don't deliver the data that you need. Okay. So with big data, idealistically, small companies will have increasing access to the data and collection from actual users. And this is where terms such as social search and social data come in. Buildings and cities can be designed using aggregated data flow of how humans behave, as opposed to how they should behave. Textbooks can be created no longer by the single sage on the page or a few of them, but by the aggregated wisdom of thousands of people. So these are the idealistic things. Of course, the less optimal thing is that you can take this technology and use it to monitor, use it to basically grab information and use it improperly, which is why things such as HIPAA, Sarbanes-Oxley, elsewhere, all those kinds of laws come into play to help protect people. I think that's important. Well, we're over time, folks. I just wanted to let you know that when it comes to CIW it teaches the essentials, especially our Web Foundation's associate certification, teaches the essentials of a lot of the things that we've been discussing today. So I'll skip the overview here in talking about how CIW is useful, because we all know that it is. But I'll get to the summary of social media analytics. We talked about this and making the most of analytics models. Leo talked to us about the importance of understanding big data and the individual elements there and his experiences with it. We are over time, but does anybody have any specific questions about some of the things that Leo has told us about in regards to big data?
James, this is Lisa. I think you've covered most of the questions that were answered in our questions panel. Dwayne Hume did add a follow-up comment, but I think you've already addressed that as well.
Yeah, that's where I got
in really good shape.
Okay, good. I'll go ahead. We'll get close to closing here then. Leo, that's where I got the question having to do about excuse me, about dashboards and things like that. It was from Dwayne. Just want to make sure I answer them. So thank you very much, everybody. Leo, I especially want to thank you for the time that you spent in talking with us about big data. It's been a pleasure.
James, it has been my pleasure as well. Thank you for inviting me.
You bet. Our next webcast, folks, is about, we're calling it Practical Magic. It's HTML5 and today's design environment. We're going to get some hands-on stuff going so that you can see how easy it is to get into HTML5 and then how sophisticated you can get with it. We'll be doing that Wednesday, November 28th. So again, this has been James. It's also been, more importantly, Leo Irakliotis working with us at Western Governors University. So thank you very much. Make sure you follow us, folks, Twitter, Facebook, on LinkedIn, and on YouTube. Those are the URLs. And again, you'll be getting a copy of this so you can see all of the URLs. So now I'll turn the time over to you, Lisa. So again, thank you, everybody, very, very much.
Okay. All right. Thank you, everyone. We'll go ahead and end the recording now. Thanks for joining us today.